We present Ego-Exo4D, a new dataset of unprecedented scale and multimodality designed for learning about skilled human activities. We believe this dataset will enable a range of new research directions, such as developing AI agents that can help humans improve at these activities, or allowing robots to learn from observing humans. We record activities from outside third-person perspectives, with 4 to 5 GoPro cameras simultaneously capturing the scene from diverse perspectives. These exocentric cameras provide multiple full-body views of the subject, as well as greater context on how they interact with their surrounding environment. At the same time, we use Project Aria glasses to capture each participant's egocentric perspective, giving us a window into how they perceive and interact with objects and their environment as they perform tasks. In addition to an egocentric RGB video, Aria glasses record with 2 wide field of view monochrome SLAM cameras for additional peripheral vision, eye tracking cameras for gaze direction estimation, an array of 7 microphones for rich spatial audio around the wearer, accelerometer and gyroscope for capturing 6 degrees of freedom head motion, and several other sensors as well. We use Aria's state-of-the-art visual inside-out SLAM to obtain 6 degrees of freedom motion of the camera wearer's head and gaze direction, as well as point cloud reconstructions of the environment. The static GoPro cameras are also aligned to the scene, resulting in a precise 4D registration of all captured video data. We do this for all 180 hours of activity recording, resulting in over 1,400 hours of localized and time-aligned video captures across the egocentric and exocentric perspectives. Our videos encompass a diverse set of skilled human activities. We choose 8 domains: cooking, bike repair, health, music, dance, soccer, basketball, and bouldering, which we roughly group into 2 categories: procedural, which tend to follow a sequence of steps, and physical, which often focus more on body pose, movement, and object interaction. Within each domain, we also define a diverse selection of tasks, providing variety. Ego-Exo4D contains over 5,000 takes recorded in 131 natural scene contexts, distributed across 13 cities worldwide. This geographic diversity captures how differences in culture, equipment, or environment can result in different ways of doing things.
I'm a classically trained pianist of 32 years.
Hola, soy escaladora hace 2 años y vengo a entrenar a Sniper.
Hi, I'm a postgrad student from India. I've been playing soccer for the last 9 years.
Over 800 participants with a wide-ranging spread of experience levels volunteer to perform activities. Our data collection efforts followed IRB protocols with attention to privacy and regulations. We developed a unique video capture rig, achieving spatio-temporal linkage with time syncing and simple scanning of the environment with Aria. Here we show a dummy demonstration of the capture process. Portability and simple recording procedures enabled our 12 research institutions to simultaneously deploy capture setups around the world. Ego-Exo4D's video capture format already provides an unprecedented wealth of scene information. But we further augment this video and sensor data with a wide-ranging set of annotations across the dataset. These annotations enable Ego-Exo4D's benchmark tasks, which we will introduce later. We start, though, with our video language annotations. We expect these time-anchored text corpora to serve as a general resource, supporting a large swath of video language learning tasks such as video grounding, representation learning, and video-conditioned language models. We first introduce expert commentary. A panel of experts, each specialized in one of the 8 Ego-Exo4D domains, provides time-anchored commentary, describing not just what the camera wearers are doing, but also how well and why, providing deeper insights than found in past video language datasets.
Great footwork. He's using a dribble to set up his footwork and his shot, stepping onto that left foot, bringing the ball up. Love that his eyes and head are up. He's already knowing where he's going to go.
A spatial drawing tool allows the experts to visually ground their comments in each video. We believe this novel annotation type will open new doors to future research in fine-grained recognition, video-based skill assessment, and potentially AI personal coaches.
And I'm going to run my finger along the inner circumference of that tire.
A subset of videos depict narrate and act, where the participant narrates their own actions throughout the demonstration in the style of an instructional video. These provide insight into the demonstrator's thought process from a first-person perspective. Finally, we have annotators provide dense, temporally grounded atomic descriptions of the camera wearer's actions as written from a layperson's third-person perspective. Having these descriptions allows for mining action and object taxonomies, video indexing, and video language learning. We next introduce a series of benchmarks spanning Ego-Exo key step recognition, proficiency estimation, relation, and pose, as well as annotations to enable them. We present these as a suite of research tasks that will push our community in new problem directions relevant for egocentric and 3D understanding of human activity. The first is egocentric key step recognition and procedural understanding. We temporally segment procedural domain videos into key steps, using a data-driven approach to build a hierarchical taxonomy. We also consult with our panel of experts to construct key step task graphs, leading to an understanding of key step dependencies in a procedure. The second set of benchmark tasks revolves around assessing a subject's proficiency level from video. We include both self-reported expertise levels and third-party expert-assessed skill level evaluations for each take. The time-anchored nature of expert commentaries also allow temporal localization of good or bad execution, as well as potential tips for improvement. Ego-Exo4D's multi-view video also presents the opportunity for benchmarks involving relating video content across extreme Ego-Exo viewpoint changes, including object instance level view correspondence matching and synthesis of one view from another. To enable this, we provide over 600,000 segmentation masks, allowing for identification and tracking of over 2,500 unique object instances across egocentric and exocentric views. Finally, skilled human activity also provides an interesting testbed for recovering cue and poses, even from extreme settings like ego-only views and dynamic environments. We provide 3D key point annotations on the camera wear for dynamic scenes, using 17 key points per body and 21 key points per hand. For easy exploration, we've built a web-based dataset browser supporting search filters such as domain, task name, or collection site. Selected videos can be played back from any of the Ego or Exo cameras, and the available annotations, including 3D scene reconstructions, can be visualized as well. In summary, we release over 1,400 combined hours of video depicting diverse, skilled human activities in a novel data format. We've defined an accompanying suite of benchmark tasks, enabled by an extensive array of annotation types, and in the paper, evaluated a number of initial baselines. Additionally, we plan to host public challenges in 2024. We hope Ego-Exo4D inspires new directions of research for the community at the crossroads of egocentric and exocentric video.